Hello, everyone, and welcome to Serverless Monitoring and Debugging. I'm Alex, and today we're going to discuss the main challenges, problems, best practices related to serverless programming and monitoring and debugging. So if you are familiar with AWS and AWS Lambda, today we will not talk just about Lambda itself, but if you're familiar with serverless, you'll be able to follow. If you're not, please ask questions, and we will have a very brief Q&A session at the end of the webinar, and so we'll be able to answer to your questions. So I'm Alex Casalboni. I work here at Cloud Academy, and today I'm here with Adam Johnson, so co-founder and CEO at IOpipe. Welcome, Adam.
Thank you, and good morning. How are you doing?
I'm good. Welcome to this webinar. So we're going to discuss, again, what are the best practices, what are the problems, how people are doing these things out there, and we will talk mostly about Lambda, but not only. So we want to be as much vendor neutral and open-minded as possible. So if you have questions about other serverless platforms, please feel free. So it's going to be quite an informal fireside chat, I want to call it. So this is Cloud Academy and IOpipe, and so later we can talk a little bit about what IOpipe does and how it all started and what you, Adam, and your team, what you guys do. So just as an icebreaker, I want to throw in a first super big question. So what's the biggest pain in serverless monitoring? And whenever you develop a serverless application, what do you think is the biggest pain, the biggest problem, and why are people struggling with this? What do you think, Adam?
So I think just when you're getting started with serverless, the great thing about serverless is that it's very easy to get started developing. Put some code together, upload it, run it. It works great. That's the beauty of serverless. But as you get more and more complex with your microservices architecture, and as you start running into production and talking to more and more external services or third-party services, whether that's something like S3 or Dynamo, or maybe a completely third-party service to the cloud you're running in, like Auth0 or something like this, all of those pieces are relying on each other for your application to work, and it becomes very difficult to monitor that, especially with serverless, because traditionally for monitoring you would install an agent on a server or VM or container, and it's watching for metrics and keeping track of the infrastructure for its healthiness and reporting that back. But with serverless, there's nowhere to install an agent. So it becomes very difficult to measure and track what's actually going on. You have to put a lot of trust into the providers that you're running on. So that's one of the big challenges that we've seen around serverless monitoring, which is what we're trying to solve at IOpipe. It's really about providing the ability to track the things you need to track, also peering deeper into the infrastructure to make sure that that infrastructure is running smoothly, so that you can rule out any issues or detect the root cause faster when you do run into any sort of issues like performance, or if it's an error in your code.
Well, I think you got you got a great point there. So getting started really quickly with serverless is amazing, but then what happens? You have 50 functions out there which are interacting with each other, and maybe you find a bug. You need to test if your hotfix works. And I think when you do this kind of stuff, as long as your function do not interact with other AWS services, that's not too hard. You do local unit testing, you do local execution, you have tools, you have tooling now to do this. As soon as you need to interact with other services, and as soon as you have a lot of functions that trigger each other, and some providers like AWS Lambda, you don't even know how many functions are being executed right now. You don't really have that kind of real-time overall view of your ecosystem, of your serverless application. So it becomes it can get really, really frustrating sometimes. And I will also say that extracting is like identifying the problem, finding where it is in the logs, and having all the tools you need to parse and transform data into information is not really painless yet. So yeah, that's the same point from another developer perspective, and which I think brings us to the next question, which is, how do you do this log inspection? Where do you find the information, and what tools you have at your disposal to inspect the logs in the cloud? Because we are we are going serverless.
Yeah, it's a good question. I mean, right now with serverless, whether you're running on Amazon or Microsoft or Google, the best source of logs for you, probably one of the only sources for you available, is their own logging services. Like in Amazon, you're looking at CloudWatch, for example. So CloudWatch will collect your standard out. You can push custom logs to CloudWatch, and then you can find those there. If you're looking at using third-party logging services, it becomes difficult because, again, usually those are requiring an agent to collect the logs locally and then send them off. The challenge is you can't install an agent in serverless. So what do? A lot of the third-party services have started using CloudWatch themselves, so they would ingest CloudWatch. So you could basically do custom metrics by putting a prefix on your logs, and then they'll pull those out of CloudWatch and then put them into their own interface. So that's one way to do it. The challenge with CloudWatch is that it may take, from our experience, it takes like minutes to see those logs. So if you're debugging or hotfixing, as you said, you have to wait several minutes to get the logs back. So that becomes challenging for debugging especially. So one of the things that we're doing is not relying on CloudWatch or the equivalent services to actually collect the logs, but instead we at IOpipe are wrapping your functions with our library, and we allow you to send IOpipe specific log messages. You do add iopipe.log and then the key value, and that can be a string or number or whatever you want to store. That will send that data to us at the end of every single invocation, and then we can aggregate that data and show that back to you in our dashboard within seconds. Usually, it usually takes less than 5 seconds. We're also collecting errors, which I think are one of the critical things when you're getting started with serverless. The one thing that you should be monitoring is errors in your application, just to make sure everything's looking good. Or if you push new code, did you introduce new errors? You need to know that quickly and where it came from.
Cool. So this allows me to find functions that had errors recently, or even to find cold starts, right?
Yeah, exactly. So we're also looking deeper into the containers. So we have access in Lambda, for example, and the other services. You have access to look at proc. So we've spent a lot of time looking into what are the things we can track. So we end up looking at things like CPU and memory utilization, and we can also look at the upstart time of the container, which helps us track whether that's a cold start or not. So that's important to know. If you have increased latency in your application, you want to look at the individual invocations. The challenge is usually the monitoring tools are only showing you aggregate views, so their resolution is maybe 5 minutes or even 1 minute. Our resolution is each invocation, which can be millions of invocations within a minute, for example. So you want to know what are the high latency invocations, and you want to know, is the cause of that because your Lambda or equivalent services starting up a new container and pulling in new dependencies. That can be slow, and if it's not a cold start, it may be, maybe it's a call to a database or some error in your code. So you want to be able to figure out what the issue may be or may not be, so you can rule out, okay, this wasn't a cold start, so I need to look elsewhere to figure out what was causing the issue. So that's what we're trying to help provide in an easy manner.
So it might be network, it might be, I don't know, I don't know if
Right.
its CPU is debuggable in that sense, but
Right.
you know. Okay, that's pretty cool. So let's go on. A new question. So what about multi-cloud monitoring? So imagine I have functions on Google Cloud Functions, I have Azure functions, I have Lambda functions everywhere, or any other function as a service provider, let's say. So how do you monitor your multi-cloud serverless application? Maybe it's not an application, maybe you're just monitoring multiple applications, but still, is there any advice you can give in this scenario? What's the best practice here?
Yeah, I think this is still a pain point that's pretty challenging to overcome. But right now, we haven't seen a lot of people running. So there's two modes, right? Run one application across multiple clouds, or run multiple applications across multiple clouds. We've seen more of the latter, where you have application A running on Lambda and application B running on Azure, for example. We haven't really seen many people do application A running across Google Cloud Functions and Lambda. So I think that those are two things that add different challenges with monitoring. So if you're looking at multiple applications across multiple clouds, I think the best thing you can do is use a tool that will provide aggregate data across all of those. There are several out there that will provide the basics. So things like Datadog or New Relic or Sumo Logic will be able to help with some of those. But when you need to dig deeper into the actual function specifics and look at the metrics tied to invocations and logging and things like that, you may need to use specific tools to do that. So that's where you may need to jump into a CloudWatch or IOpipe. So IOpipe right now only supports AWS Lambda. We do want to support other providers, and that's definitely on our roadmap. But I think the best thing you can do is use the monitoring tool that you're using right now. Pipe in the most basic metrics you can, just to at least figure out if there's issues, and then when you do find an issue, you can look at that specific cloud, because especially if you're doing one application per cloud, it's very easy to pinpoint where you need to start looking.
Cool. Yeah, I haven't seen too many multi-cloud solutions either, but what I've seen is that now you have the tools. Imagine you were using the serverless framework, for example, and now you have OpenWhisk and Azure support. So as soon as that development layer becomes like a commodity, it's not a commodity yet, but imagine in another year, I can develop my function in any cloud provider I want. I can just give it a try and see how it works, and then I like it. And then maybe what I have seen is that maybe developers are using serverless functions to actually integrate different systems. So I don't know, you have a DynamoDB trigger, and you want to sync that kind of data into another Google Cloud database, for example. You might think of using functions to integrate other data or to sync services or stuff like that. So in this case, you actually have a dependency, like one function in one cloud calling another function in another cloud, which is even more complicated. But
yeah, exactly. I think if you're building that kind of complex logic, your best solution right now is to kind of build your own, right? So you could take a approach like we do and create a wrapper and send logs and metrics to like an Elasticsearch, for example, and then monitor that. That's probably the best option out there today if you have that kind of complex logic and you need to have better debugging. But I suspect that tools like IOpipe and others are going to mature and be able to provide that kind of monitoring as well. So I think it's coming.
Yeah, that's true. I think some cloud providers are actually working on some kind of hybrid logging service. I think Google is.
Right.
I can't remember the exact service name, but I think they just acquired maybe last year or a couple of years ago a service that does like hybrid AWS and Google
Yes.
logging, monitoring. It's not really like functions or microservices monitoring. It's more about logging, to centralize the information and then eventually parse it and fetch it and build dashboards and stuff.
Yeah, I think that's Stackdriver. Is that right?
Yeah, I think that's Stackdriver.
Yeah, that's a great service. Yeah, so that's one option for sure to check out if you're using AWS and Google. I think that might be a good solution.
Yeah, that's interesting. I haven't tried it, but if any a student or listener is using it or have a question, let's see. So next question. What is the best way to debug a serverless application? So the use case here is it will happen to everyone, to anybody. You write some code, it works, you push it, you use it for 6 months, and then something changes, the SDK changes, the whatever changes, and there is a bug, and you have to fix it. And as I was mentioning, if you are not interacting with anything, if it's just an algorithm, if it's just input, function, output, no problem. Maybe you just do it locally, you debug it for weeks, and then when you know it's fixed, you just push it and you're happy. But as far as I know, in like 90% of Lambda function and Google functions, you are actually either receiving a trigger or an event from the environment or reacting to something and interacting with services, like creating a new S3 file or sending an event to IoT or writing on Kinesis or calling an API call whatsoever. So what's the best way to tackle this kind of problem and to debug your application? What do you think, Adam?
It's a challenging topic. So I think like the first thing to note is that there's a lot of overlap with regular application debugging. So the best practices for app development and debugging apply to serverless quite a bit. But there are other challenges, like you said. There are external triggers, and you're relying on external services, which makes it very difficult to do things like testing locally. And so I think that the trick is to first, the number one thing you can do is capture an alert on errors. That's the first thing that's easiest and the most fundamental thing that you can do when pushing serverless applications into production or even in development mode. And next would be to look for any sort of correlations or changes that have happened when you notice a problem. Start looking at what's changed over time. Has there been any changes to my IAM policies, or has code changed? And figuring out what your kind of dependency tree looks like for the whole serverless application, right? You may have 10 functions talking to each other and then talking to 5 other external services like databases and whatnot. So that becomes challenging. You need to have a good picture of what you're looking at a high level, and then look at the changes that have happened, and then try to eliminate any common factors that as quickly as you can. So for example, if you see latency happening that's affecting users, start by ruling out cold starts. So start by looking at the slowest invocations, and then see, are these invocations that are slowest cold starts, or what percentage of them are cold starts? If it's low, then you can move on and figure out what's next, right? Are these functions calling external databases? Then start tracking the time it takes. You can, in IOpipe, for example, you could do this in CloudWatch probably too. You can basically time calls to third-party databases and then report that back and see what does that look like over time. Has that increased? So if maybe someone tweaked the query to Postgres and that's causing a slowdown, or maybe it's actually a network issue between those two services, which is much harder to diagnose.
Yeah, true. Sometimes it's even just the trigger that's coming to you that just changed the syntax or whatsoever. So, I mean, provided that you found a bug. Thing is, maybe I have a local environment. How do I fix the problem? So, what developers are used to do is to have a local environment. You test it. You write a new test, and then you run your test suite, and hopefully everything works fine, so you don't have regressions and stuff like that. So what I've seen around is that people build a lot of tools to mock what's going on in the actual online environment. So imagine you were working with DynamoDB, or you're working with S3, and people have built tools that behave kind of like the real services. Like there is a local DynamoDB service, or you can kind of wrap your code and your tests to simulate what's going on, and that would help you to actually get around and find the problem, solve it locally, and then push it online when you're sure it's fixed and stable. But that's simulating AWS is not easy. Simulating Google is not easy.
There's
so yeah, like 50, 60. I stopped counting.
Yeah.
But just yesterday, I think, did you see Atlassian open sourced a tool called Local Stack that is kind of using all the available tools and building on top of them to provide kind of a local AWS environment, and that's pretty interesting. I haven't tried it yet, but it's a very interesting solution. It's also Lambda, and it's also Dynamo and S3 and Kinesis, and you can kind of have the same triggers and functions and APIs on your machine offline. You are on a train and you can debug and push and not fix, making sure it's working. You don't have to trial and error is not the best way. So I'll give it a try, and if you guys already gave it a try, please let us know what you think. So yeah, debugging is a problem, especially when you go with microservices. The complexity can explode, especially if you have dependencies, and if you cannot simulate or mock properly the behavior. Integration tests are complicated in a serverless world. I think if you follow the microservices best practices, it's a very similar approach, so you will be covered for the most part. Okay, 5, and that's next step. Will this local unit testing and mocking, which is what people are kind of forced to do, ever disappear? What do you think? I'm not sure.
Yeah, it's tricky. I mean, and we've seen different opinions from different cloud vendors as well. Like some are pro local unit testing, and some are like do everything in the cloud. And I think it is challenging to do it locally, especially with all of the massive number of services that you're integrating with. So I suspect that like the only way for it to really take over is by having some sort of IDE that runs in the cloud. That's great, but people are very religious about their editors. So I think it's very hard to convince everyone to do it all in the cloud. So I think that local unit testing and mocking is going to be here for a long time. I do suspect there will be big improvements happening where you can do a lot more in the cloud, or that maybe there's some unique tools or tricks that are coming out. Like I've seen people do like proxies to AWS services that you're running locally. That's interesting. So it's,
I think the problem is that not every service allows you to have kind of a dev or test environment. Like, okay, Lambda and API Gateway, you can have multiple stages or multiple versions or aliases, blah, blah, blah. But you can't have the same, or it's painful to have a configuration for different buckets, different Kinesis streams, or different IoT applications, or having a completely different and complete environment for each stage. Sometimes it's not really possible, especially when you integrate with third-party services. Like inside AWS, it's not too hard to replicate everything. But imagine you are.
If you can do that though, you should do it because we use a lot of Lambda and a lot of third-party services for IOpipe, and we have like multiple whole environments set up. It is very expensive to do that, right? Because you end up running several databases and Kinesis streams, and it's complicated. But I think it gives you a lot of peace of mind because it may be not easy to do it for all of your developers, but at least for staging, I think it's very important that if you're making critical changes to your application architecture, you need to test that before you push it live.
True.
And at least have some sort of burn-in phase where you're confident. But it is very challenging to do, and I think like you're right, it's not possible for everyone to do that.
So regarding AWS, only, I've seen a clear shift from infrastructure as a service, and now they're covering more the application layer with like Lambda and AI and very higher level services. Do you think at some point that every cloud vendor will go into a direction where they help you debug and they give you kind of a debugging service or something like that?
I think so, for sure. I mean, you saw like Amazon acquired the Cloud9 IDE, which they must be doing something with that in the near future, I would imagine. And if you look at the other vendors like Microsoft and Google, Microsoft especially has great developer tools. They've always had a great developer ecosystem, so they're very comfortable with providing that kind of tool set. So I think you'll definitely probably see an arms race happening where you're providing more tooling to the developers because developers are becoming more critical as things go serverless. It's mostly just happening, things are just happening in the application layer. There's less and less in the infrastructure layer, so you have to tailor to your audience, and I think that's a shift that's happening. And I think that vendors like Amazon understand that, but it will take some time to develop tools that people are happy.
I think the same exactly. I think Google is already doing something, but not for cloud functions. I think if you use compute engine, you have already a great debugging and testing and blah blah blah. It's not coming to serverless yet, but I think that's why Cloud Functions is still in alpha version. So they want to make it right.
Right.
Hopefully.
Yes.
We'll see. Okay. This is true. What about cost optimization? Do you think it's a monitoring problem? What can you do when you have better monitoring tool about cost optimization?
This is a really interesting topic to me. I think that right now we're in the honeymoon phase of serverless, where if you're moving your application from EC2 or containers to Lambda, for example, you're probably seeing a pretty big cost savings. We've seen users who are saving upwards of 10x on their AWS bill. That's pretty incredible savings. That doesn't happen very often. It happens in the infrastructure world maybe every 15 years. So that's really exciting, and a lot of people going serverless are amazed at the cost savings. So they're not caring right now about optimizing costs anymore within serverless. But I think as the honeymoon phase wears off, you're going to end up where businesses are looking at more specific costs. It's easier to measure the effect of code changes to the cost of your infrastructure, because if you write a slow algorithm, that may end up costing you more, and it's very easy to track it down to that specific thing. Previously, that was all hidden inside VMs and containers, right? Because you could have slow code running, but it's not obvious that was the reason why you needed more servers. But in Lambda, you're charged per compute time. Now it's very easy to track that. So I think that that's going to be a big factor for a lot of businesses as they're moving more and more serverless. They're going to start looking at, which developers are saving me the most money, or there's trade-offs as well, right? It may cost more but it delivers the data faster. And being able to track these over time is going to be a very important thing. But I think it will probably take a few years for that to become important for a lot of people.
True. Well, I think that's true, and it becomes more important when the size of your serverless application gets bigger.
Right.
Because you have a pretty good free tier if you're a startup, or if you have a side project, or if you have a reasonable amount of invocations. Imagine you are a big enterprise and you want to decide whether to use serverless or not. And if you have, I don't know, 100 million invocations per month because you have a huge system, well, then the assumption that you're saving money is not granted. So I think monitoring can help with optimizing costs. Not only about finding which part of your serverless application might run faster because you are built depending on the compute time, but also about sizing your Lambda functions, because the size that you choose affects both the performance and the cost. So another problem that everybody is having is, how do I size? How do I choose the power or the size or the RAM, the memory allocation, which is also CPU and networking capabilities of my Lambda functions? I don't know. I'm not sure if it's the same problem with Google Functions and Azure and OpenWhisk. I think this is more related to Lambda in AWS. But so people have this problem. How do you size it? And I haven't seen any solution. The solutions, the tools I've seen are more oriented towards the cost estimation. So I will help you estimate how much you may end up spending. Optimization is a different problem, and I think you can't really do it without monitoring or with a good simulator or something like that.
That's true. Yeah, I mean, we do track the CPU and memory utilization of every invocation, so we can show you those metrics, and you can basically look at that and see if you're very much under provisioned or over provisioned. Previously, if you're using just CloudWatch, for example, it is challenging because we asked a lot of Lambda users out there, how do you choose the right tier? And there are 23 tiers to choose from, by the way. So how do you choose the right one? And they just pick a number, and then if they hit the out-of-memory error in CloudWatch, then they raise it up a few notches. It's kind of cumbersome to figure out the exact right number. So we actually graph that for you so you can see, okay, over the last 7 days, for example, my application never used more than this amount. So I know you have a better idea of where to put that tier. Though there are more nuances to these decisions because memory and CPU are tied together, which means that maybe you don't need a lot of memory. So if you use a lower tier, you're actually getting less CPU, and your functions may run slower, which actually may end up costing you more. So
true. Or you may end up with throttling, because if every function takes a bit longer and you have a limited concurrent invocations limit, you may get to that limit and be throttled. So running faster is good for all these aspects. Okay, let's keep going. What problems are still completely unsolved in the serverless world? This is a very broad question. Do you have any thoughts on this?
Tons of problems. There's, I mean, one of them is as serverless gets more mature. We've touched upon it several times now, but as you get more and more functions talking to more and more services, that's a very complicated graph that is very tricky to monitor and debug over time. So I think that tools need to get better. There are some emerging, like Google has a trace tool that may be very useful for this, and then there's X-ray as well, which can help. But I think there's more that needs to be tied together in order to have a comprehensive picture. You don't want to end up using a bunch of different tools to get a single picture of what's going on. So I think that's one challenge that needs to be solved. I think there's a lot of challenges in security that need to be solved, especially as you're using so many different services. And again, like the whole debugging development and debugging space needs a lot of work for sure. Those are the big ones that we spend a lot of time thinking about. I'm sure there are a ton more.
Yeah, that's true. It's, if you start simple, everything, as you mentioned previously, getting started fast and everything works just fine. But then, we are realizing there are problems, and it's amazing that the community is working hard to solve them, with better tooling, with better integration from the provider side, with better, monitoring services like IOpipe. So this is getting better every day. And more complex every day. So it's like a, a double effort, people using it more and finding more problems and then working hard to solve them. I think this is a pretty good sign. This technology is here to stay, but let's see, let's see what happens this year. I think this is a pretty interesting year for serverless because tools are evolving very, very quickly.
Yeah, absolutely. I've been very surprised at the speed of adoption and interest in serverless in the whole serverless space. This last year has been pretty incredible. So I'm pretty excited about the future.
Exactly. And I have one more question. This is more related to what you guys do. So we have mentioned a few problems, a few missing things in the serverless world, and what of these? Which of these are you focusing on at IOpipe?
So we started by focusing on the really fundamental issues of visibility and instrumentation around Lambda, because that was the biggest pain point that users told us when we started IOpipe. We started to talk to 30 or 40 different companies using Lambda in production. And that was the theme that everyone came back with, was it's just really hard to know what's going on. So we wanted to solve that issue. So we built a monitoring service, which is kind of a mix between an infrastructure and an APM solution. So basically we provide a library that you install. We support Node.js and Python right now. So you'd install our library and you wrap your code, or in Python it's very easy, it's just a decorator. So it only takes a minute or two to actually integrate IOpipe. Once you run your function, it's going to collect information about that invocation. So it's going to look at the duration, it's going to look at your CPU memory utilization. We're looking at like which container that's actually on, so we can track how many containers you're actually running across at any given time. We're looking at cold starts, and we're looking at errors and sending those back to our service on every invocation. And the trick with monitoring in the serverless space is you need to have very high resolution, because most traditional monitoring tools are very low resolution because it's a lot of data. So we built our architecture from the ground up to have very high resolution. We can actually show you every single invocation. We're not sampling. And then you can track the aggregates, of course. You can look for errors, and you can dig down very deep per invocation and see this invocation what was actually happening, to figure out is this something that I need to focus on, or is it just something that's like a cold start and not much you can do about it. So that's what we're trying to solve right now. This is what we have, and we do alerting that will tell you if there's any issues within a minute. So very quick, very fast response. And our vision is to make serverless as easy as possible. So we want to find ways to help debugging in a more easy fashion. We want to be able to make solutions for these very complex challenges of running lots of functions and lots of serverless services, and provide a view that shows you the whole picture and track the changes, so if you do have an issue, what's the likely root cause of that in a short amount of time, without having to jump through 5-6 different tools to figure that out. So these are the things that we're working to solve at IOpipe.
That's great. I think you guys are doing great work, so keep up.
Thank you so much.
You're welcome. So we do have a few questions. So we didn't go very deeply with some topics, and we didn't, we assumed everybody had some kind of background about serverless. So, for example, we didn't explain what cold starts are. So, some people asked, "What do you mean by cold start?" Can you explain that?
Yeah. So basically, your Lambda functions. This works pretty much the same across all of the serverless function as a service services out there. Basically, your function is running, and behind the scenes, it's running inside a container, and then sometimes it's also running inside a VM, and that container is being reused on every invocation. So your code may run for 200 milliseconds, and then it stops. You're only billed for that 200 milliseconds, which is the great thing about serverless. And the reason that they can make this happen so quickly is that they keep the container running as your function is active. So if you have requests happening, every few seconds, it's going to continue to keep that container running so that it doesn't have it doesn't take time to actually spin up a new container and pull in maybe external resources like dependencies. That takes time when you do that. So when that happens, when you start a new container, or when the provider starts a new container, that's called a cold start, because it may take several hundred milliseconds to several minutes, depending on what code you're actually running. The worst case we've seen is 3 minutes, but that was for a very large Java application, and that was okay for the user because the way they were using it didn't really have any impact to the end users, the way that they architected it. But in general, your cold starts will take somewhere between 100 to 500 milliseconds. You can keep your functions warm maybe by kind of continuing to run that invocation every minute or two. We've seen that if you don't have a invocation within 5 minutes, they're going to shut down your container. And if you even if you have a function that's running continually and is very active, we've seen that you will still get a cold start happening somewhere between 2 to 4 hours, every 2 to 4 hours. They're presumably they're doing some bin packing to make their infrastructure more efficient, so that they can keep the costs down. So that's probably what's happening. And then if you're scaling, if you have a ton of requests come in, they need to spin up more containers to handle those requests. So you'll see cold starts happening then as well. So we track that and we provide that to you. We also are doing some studies to understand what are the impacts of that and get more specifics on when those are happening. But I did write a blog post not long ago on our blog at IOpipe on cold starts. If you want to know more, feel free to check that out.
Mm-hmm. Well, because you're paying for that time anyway, aren't you?
Right, exactly.
So yeah, it makes sense to know it. And but wow, 3 minutes. That's interesting. And I've discussed I have discussed this problem with Austin Collins and other people from AWS, and I asked them many times why don't you let me pay a little bit more and just avoid this problem? I'm willing to pay.
Yeah.
It should become a pay, something I can choose. I don't really want to, and I will pay 5 times more, 10 times more. Why not? So maybe we might see some improvements on this, hopefully.
Perhaps. Yeah. And we have seen improvements happening with we've tracked Amazon. We've seen improvements happening over time where they actually have lowered how long it takes to create a new container a few times. That's happened. And they're pretty quiet about it, but there are silent improvements happening to Lambda, and I suspect the other cloud providers are working diligently on that as well, because it's an issue that always comes up.
Cool, that's good to know. So next question. So someone asked, so what do we think of Amazon X-Ray? Because it's still in preview, right? And it looks like it can do metrics collection for every single invocation. So it will be hopefully very precise, and maybe it will give you an overview of the whole system. So what do you think about this upcoming service from AWS?
I'm excited for the future of X-Ray. I think that it's a tool that's very necessary, and I think that there are things that Amazon can see that like IOpipe and others cannot see. So if we have access to that data, that's great, because our vision is to basically collect as much information about your serverless application as we can and track that over time and provide a comprehensive view of here's how your application is performing, and here are all of the things that have changed if you do run into an issue, so you can find the root cause in a very quick manner. So I'm hoping that X-Ray improves very quickly and is released very quickly. But I from looking at it early, a while ago, it looked like it still has a ways to go. For example, you have to run a VM to collect the metrics locally. I think if you're going all in with serverless, you shouldn't have to manage VMs. So hopefully that changes as well and that improves.
Totally, yeah.
But
I do not have access. Sorry.
No, go ahead.
Yeah, I do not have access to the preview, but it sounded promising when they announced it. So I'm very curious as well.
Yeah.
So another question was when we mentioned the multi-cloud thing. So what do we mean? Public, private, or hybrid? Well, when I mentioned it, I actually meant using more than one cloud provider, public, like Google and AWS altogether. But in a way, yeah, you could think of having a private cloud or your own on-premises infrastructure, and that could be, if you have functions, there are ways to deploy your own function as a service layer or abstraction layer. So if you have the same function in your own infrastructure, you may think of having the same monitoring problem. So yeah, also private in a way, although I haven't seen that happening very often. What do you think, Adam?
I mean, there are a lot of projects out there, open source projects that help you run your own function as a service. So like OpenWhisk, for example, is open source. There's another one called Fission. I actually counted, I think, 8 or 9 at some point. So there's a lot of work being done, but I think there are some challenges to running functions on-prem. Like, you're not getting the cost benefits that you get by using the public cloud, because you're essentially just running containers all the time. And I think the cold start issue is amplified there, because there's just less improvements made to the container startup.
Right.
In the open source world, I think the cloud providers have done a lot of tweaking to make that very quick. So I think that it'll take quite a bit of time for the on-prem solutions to catch up, but it's promising. There's a lot of work being done there. And but I agree. I haven't seen many people actually running locally in their own private cloud, but it's doable. But I think the monitoring challenges are similar, right? You want to have a tool that can aggregate data across multiple clouds.
That will be ideal indeed. So I would say we have one last question. This is related to IOpipe. So what is the perceived overhead of the IOpipe decorator in JavaScript or Python? So I'm presuming it calls the IOpipe API to send the metrics. And do you provide visibility and instrumentation about the IOpipe wrapper, so I can make sure that it's my own code and not the wrapper to cause errors or delays?
That's a good question. Yeah, so the overhead of IOpipe, we're trying to make this as little as possible. So the actual dependency size, we're working on minimizing. I think it's around 3 megabytes right now if you include all of the dependencies that it pulls in. And then the actual overhead of IOpipe itself is pretty minimal. So what happens is we're not making any calls until the end of your execution. So at the end of your code, at the end of all your code running, we will then wrap that data up and send it to the IOpipe service. We run an API collector in every region, so it's hitting the local region. So the biggest impact is going to be just the network latency to that endpoint, which is very low. So it should be, something like 50 milliseconds or less. And we're improving that. In the last week, we did some improvements to how we're handling secure connections in a more efficient manner, reusing that across invocations. So that has helped lower the overhead by something like 85% in the last week. So it's pretty low at this point. And you can verify that yourself by looking at our reported time and then looking at the CloudWatch reported time. It's going to be different because our reported time is how much time your code runs from the beginning of IOpipe to the end of IOpipe, which wraps your code. And the CloudWatch time is from the start of the container to the end of the container. So you can do some math between CloudWatch and IOpipe to see what that overhead is. That may be something that we could actually pull into IOpipe, so you don't have to do that manually, so you can track that as well. That's maybe something that would be useful to users.
Thank you. That's great. So we have a couple more questions, but we are running out of time. So I will collect them and eventually publish them on our community, or maybe write a blog post and, of course, answer. Thank you so much, Adam, for joining us today. It's been my pleasure.
Thank you. This was great.
And thank you, everyone, for attending. I hope you learned something new and you have some new questions for the next time. And if you have any doubts, please get in touch with me on Twitter or on the Cloud Academy community. You know, you always have questions. I'm here to answer. So thank you, everyone, for joining, and I'll meet you at the next webinar. Thank you, Adam, again.
Thanks, everyone.
Bye-bye.
Bye.